2022 October, November, paper 22. Finish off with our question. Are you happy with this question part that we have covered? Now you cannot assume P and
Yeah,
Q
teacher,
resistance.
I just don't know why the current is different.
Current is different. It cannot be. If they are same resistance, then the current will be the same.
Oh, because it's a different resistance.
They are
So
different
different
resistance.
amount of
You
current
cannot
goes
assume
inside.
it's the same resistance
Oh, okay,
unless
okay.
they tell you it's the same resistance or identical resistance. I cannot assume that. So they have a reason to want to test you different things. They want to test you your formula I equals Q over T. So that's your current through here. That's why the current is different. Okay.
Yeah.
Potential different across P. How do I calculate that?
7.4 volts.
How do I calculate?
Power over the current.
They didn't give you
Power
power.
over current.
They didn't give you power. They give you work done divided by charge. So it's 7.4 volt. Okay.
Oh, teacher, the power I just derive it four
You
thousand eight
derive the
hundred.
power.
Yeah, 4,800 over 540.
Is there anything in the question that can calculate power?
Yeah, they got give the time interval.
They give you, you use this energy divided by time to get power. Can, also okay.
Yeah,
Internal resistance of the internal resistance out of the battery.
0.4.
Right? You use Kirchhoff's current law. The current through the battery is equals IP plus IQ. So E equals to IR plus V. Potential difference across here is V. And R equals to E minus V over I. Okay, 0.28 ohm. Agree or
Oh, I got it wrong.
where did you get it wrong?
Uh,
Where did you get it wrong? Or anything you don't understand from my calculation?
oh, I didn't use Kirchhoff's seconds law. I use the EMF formula.
EMF
Oh,
formula,
so
but
it's a
you still have to consider the current passing through the battery. Or
Kirchhoff's second law. This one.
this one is Kirchhoff's second law lah. This part we are using Kirchhoff's second law. We are combining the resistance so that the potential difference across this one, which we have already calculated 10.4. That's the reason why they asked you to calculate. Can anything don't agree?
Um, 7.4.
10.5 is the potential difference across
Wait.
P and Q. Right? It's across P, so you across Q the same. Only the current which across passing through P and passing through Q is different. They are different resistor.
Oh, teacher, so 7.4 is applied to
P
Q
and Q,
also.
P and Q.
Oh,
Because the potential difference across P and Q is the same.
oh yeah, it's just the current and the
Current
resistance
is different, that's
different,
all.
right?
Then
Ah,
anything still not clear?
no.
Okay, then describe the structure of atom of uranium 238 and 92. Yep. How to describe?
Is it unstable nucleus?
No. Describe, they give you the
Oh,
formula. So from the formula, you can tell the number of proton, number of neutron. 92 proton,
okay.
146
92 proton, yeah,
neutron,
92 proton.
and then 92 electron. No? Since they say atom, but they don't consider that. They just want the nucleus. Oh, 92 orbital electron.
Oh, what's orbital electron?
The number of electron no? In the orbit around the nucleus. Okay,
How do you know it? Is it because of the proton?
same.
Proton number
The number of electron and number of proton is the same.
for all, is it?
For all atom,
Oh, okay.
neutral atom, number of electron, the number of proton. No? Okay or not?
Yes.
Decay of uranium-238 is shown by the equation, that one. For nucleus X, calculate the ratio of Coulomb to the charge to mass ratio. So have to calculate what is X, right? A for X is 238 minus
Of 4
234.
particle.
So it's 4. Z is 92 minus 90. So it's 2. So charge is 2 electron. Mass is 4 U, for atomic mass unit. So that charge is 2 times 1.6 and 10 minus 19. This atomic mass unit times 4. Then atomic mass unit, you convert it to kilogram. Look at the data sheet. 10.
Yeah.
Okay. Two particles P and Q each consist of 3 quarks. These quarks are up or down. Quarks particle P has no overall charge. Particle Q has an overall charge of 2e. Where is E in the E is the elementary charge. State the quark composition of P and Q. Yep.
Quark composition.
That means it can be
Two.
up, down, jump. So you have to decide the right one. No? That's been a
Particle
composition. No?
P.
R.
Particle P. One up, two down. Up, down, down.
Right, so you're working. No? It is no charge there. So it's 2/3 E minus 1/3 E minus 1/3 E. No? So up, down, down. No? Correct. Particle Q.
Up, up, up.
Up. Okay. Okay. Let's go to the next question, next topic, next paper.
Teacher.
Yeah.
Let's say the percentage uncertainty, right, is like plus minus 3%. So is it just 3% of the value? The percentage of uncertainty? Is it 3% of the value?
Yeah, 3% of the value. No?
Oh, okay.
Okay, let's go to okay, 2022, October, November 23. Rate of flow Q of liquid along a narrow pipe of length L and radius given by the equation that alpha is a constant. The experiment is carried out to determine the value of alpha. The data from the experiment is shown. The data. Use information in table 1.1 to show that the SI unit of alpha. What's the SI unit for alpha? Object alpha?
Per second.
Per second, okay, correct. Show that the percentage uncertainty in alpha is 15%. Same, use the
3%
same
plus
equation
4%.
that you have subject. That's the equation. And percentage Q, percentage uncertainty in Q, percentage uncertainty in L, power 4 times, so percentage uncertainty in R. So it's given here. Can any comment?
Yeah.
Then calculate alpha with absolute uncertainty. Give your answer to appropriate number or significant figure. So alpha, put in your value, right, that you can obtain from here. Calculate out. Then
1.6,
this
2.68.
15% is delta alpha over alpha times 100. So alpha is
0.4.
always
Yeah.
one significant figure. So right,
Okay.
any comment or anything not clear?
Uh, Uncertainty can either be absolute or fractional one, right?
Usually they will put it as a decimal
Absolute,
rather than fraction.
Also, they usually ask for absolute uncertainty, like delta A.
Like this 15% is percentage uncertainty in alpha. No? So there is delta alpha or alpha times 100%. No? Then you take 100 across and alpha across. No? Then calculate your delta alpha. Did I answer you correctly? Any query?
Because I don't know what symbol to write for the second one.
Say again.
Uh, Percentage uncertainty means percent delta alpha lah.
It
Not
means
not delta over A,
delta
right?
alpha over alpha times 100 no? Is 15%. No?
Oh,
Okay, now
how
that's
come you
it.
write? How come you wrote percent delta alpha only?
This is my short form lah. They are not worried about the short form lah. They are only worried about this value here. Right? The 4 is because the
Okay.
power 4. No? This is my short form lah. Right? My short form is lazy to go and write percentage uncertainty in Q, percentage uncertainty in L, percentage uncertainty in R. Lah. Okay, any comment?
Yeah, never mind. All right.
Okay,
Uh,
engine of a toy rocket pushes gas vertically downwards, and this results in the rocket accelerating vertically upwards from the ground. The rocket starts to move from rest t equals 0. The variation with time t of the vertical velocity v of the rocket for the first 0.3 seconds for the flight is shown in figure 2.1. That's the diagram. As the rocket moves, the thrust force T provided by the rocket engine is 60 Newton. Assuming that the mass of rocket is constant for this part of the flight, assume air resistance is negligible for this part of the rocket's flight, show that the acceleration of the rocket is 55 meters per second. No? So how do I find the acceleration?
Gradient.
Uh, Right? Make sure you use a ruler to help you read correctly. Best is to use the corner one, easier lah. No need to go and read elsewhere, you know. So that must be there lah. A equals the gradient lah. Gradient can take any point lah on the straight line. Okay, agree with my answer?
Yeah.
Okay, let's carry on. Say an expression for the resultant force X experienced by a rocket in terms of thrust and weight of the rocket. So you should get your F equals to
G
T
minus
minus
W.
W. Right? Have a picture of, if you don't want to draw, just imagine what is happening. No? Thrust is greater than weight, that's why it's thrust minus W. Resultant force ours. Calculate the mass of the
Or
rocket.
if the rocket is falling down, right, then it's
If
W
it's
minus
falling
T.
down, then the weight is greater than the thrust. No?
So W minus T.
So it's moving up, this one. So there is T must be
But if it's
greater than
falling down,
W.
then
No?
it's
Mm.
W minus T. If going down.
Yep. T minus W no, for this case.
What if it's stationary?
Stationary then T equals to W, no resultant force.
Oh yeah, that's true. Okay,
So it
okay.
depends on its motion. No? If it's moving, then it continue to move. No? If it's stationary, then it
Uh,
remains stationary. No? Right? So the resultant
so
force is MA. No? That's your T, that's mg. No? So calculate your mass. No?
T.
Right? Take this one across there. So you divide, put your value in. No? 10. Anything don't
Oh
agree?
yeah. Oh, I just straight away took MA equals 16. Yeah.
Cannot.
No.
You
That's
must
wrong already.
subtract the weight. That's the reason why they ask you to calculate this one. So F equals to MA. And T,
Yeah.
E, and W equals mg. So the calculate math, take this one across. A minus A plus G. A plus G. Okay,
Yeah.
E equals 0.3 seconds. A small piece of metal separates from the rocket. Calculate the height of the rocket above the ground. This one is motion kinematics. Taking ours as positive, U equals 0. Choose the right formula to use.
5.39.
2.5 meter. Okay,
Oh wait. Final velocity.
okay now.
Oh wait, something went wrong. Wait.
Initial speed is 0. Then final velocity is 16.5. Use the graph to help you. And then we have calculate the acceleration. And t equals 0.3 knot meter per second. Can or not? If not, I go
Yeah.
over there. Use the graph. Use the graph. Initial speed is 0. Initial velocity is 0. And then after 3 seconds, there is your read from the graph. Okay or not?
Yeah.
The speed at which the piece of metal strikes the ground. Yep, agree with me.
Um.
This part we are calculating when the initial speed is 0. This one, the speed at which the piece of metal strikes the ground. So it has a speed initially, and this acceleration negative because we take upwards as positive, and then this is downwards. That's why I put a negative sign there.
Okay.
Okay, then we carry on. Velocity is upwards for metal initially, and displacement is downwards. This Thursday, I'm not free.
Yeah.
So you want the class on Monday, Tuesday, let me know. Say the principle of moment. Okay. What is the principle of moment?
Uh, com uh, clockwise moment equals to counterclockwise moment about pivot, then is equilibrium.
Sum of clockwise moment equals sum of anti-clockwise moment about the same point for an object in rotational equilibrium. Okay.
Ah,
A hollow plastic sphere is attached at one end of a bar. It's a hollow sphere. The sphere is partially submerged in water, and the bar is attached to a fixed vertical support. The vertical support at the pivot P is shown as water level. The sphere has a weight of 0.3 Newton. The distance from P to the center of gravity of the sphere is 0. They draw for you in the diagram. Assuming that the weight of the bar is negligible, you don't bother about the weight of the bar. Calculate the moment of the weight of the sphere about P. This is an easy mark to get. You just want to check. Can don't be afraid to draw on the diagram. Can or not?
teacher, but like, how do you see the angle?
How do you
40
see the
degree.
angle?
Oh, wait.
Yeah,
Yeah, because like submerged is submerged partially inside the water,
this is 40.
and then
If you draw the line here, this angle is 40. So the angle must also be 40.
but in water I thought the weight is a bit heavier, got like upthrust or something,
This one is
like
not
buoyant.
enter the water yet.
Oh,
They just in the process of entering the water, they just want you to find the easy mark. Tells you about moment. Yeah, this is 40. This part is 40.
okay.
Okay, so this is your first mark to get off. The system is shown in figure 3.1 is part of a mechanism that controls the amount of water in the tank. Water enters the tank and causes the sphere to rise. The result of the bar becoming horizontal. Figure 3.2 shows the system is in new position. The position of the rod R exerts a force on the compressed horizontal spring that controls the water supply to the tank. R is positioned at perpendicular. They give you the distance. Here's your R. Okay. Draw the diagram so they can picture there's your upthrust. It's now submerged in water. So there's your upthrust there. Right? Volume is the volume below the water. And then the weight of the sphere is downwards. Right? And then there's a force there. Okay, variation of force applied to the spring if the compression X of the spring is shown in figure 3.3. Use figure 3.3 to calculate the spring constant. So as I said, it's easier to read the endpoint. Use a ruler to guide you. Okay?
Oh, teacher,
Any
this
comment?
one obeys Hooke's law, right?
Say again.
This spring does this spring obeys Hooke's law, right?
This one is just to test you about the spring, that's all. Spring constant.
Oh,
Not they try to relate to the question later on. But this is a simple mark for you to get. Spring constant from the graph. Okay? K equals to F over
yeah,
X. So X is the extension. Make sure you change the unit to meter. This one. Any comment?
no,
Okay. So 10 more minutes. At position shown in 3.2, the system is stationary and equilibrium. The radius of the sphere is given. 26% of the volume of the sphere is submerged. Density, the water is given. So the upthrust is 1.18 Newton. So get the volume of the sphere plotted by R cube. Plus formula, get from a formula sheet or memorize it. Yep. Can
um,
anything don't agree?
yeah, then
Taking moment of P determine the force exerted on the string by the rock. Now, clockwise moment about anti-clockwise moment. Okay, now.
1.18.
Yep.
Wait,
Yep. Don't
uh,
ask. I'm using clockwise moment, you got anti-clockwise moment.
wait, teacher, the weight equals the upthrust.
Look at the picture. Yeah, bit long. There's the upthrust. Yep. Anything not clear?
Yeah,
Okay.
but does the weight equals the upthrust?
Yep. Say a bit louder.
Is the weight equals to the upthrust?
Uh, the weight. How come the weight doesn't come in? Oh, you are looking at the force exerted by the string on arrow. So you are not considering the weight. It's the upthrust that is that's causing the outward, the clockwise moment. The spring will cause a anti-clockwise moment. Yep. That
Also, don't need to consider weight.
anti-clockwise for pivot for the pivot is upthrust. Okay now.
Okay.
Okay, yeah, okay, let's carry on. Calculate the elastic potential energy of the compressed spring.
Half Fx.
Okay, 0.53 joule can get. Can or not? Refer to the previous
Yeah,
question if you
can,
are lost.
can.
15, 15. Read from the graph. The extension. That's the reason why they ask you to calculate 15 extension of the graph. Can or not?
Yeah.
When the sphere moves from position shown in figure 3.1 to position 3.2, the upthrust on the sphere does work. Explain why work is done by the upthrust is not equal to the gain in elastic potential energy of the spring. Okay?
Um,
Yep.
is it because they didn't consider the weight?
Sphere has gained gravitational potential energy. Okay, not? Sphere has gained
Gain.
gravitational potential energy. We didn't consider that.
Oh, okay.
Yeah, that's the reason why we have the weight of the sphere. Okay,
Yeah. Teacher, then the resultant force, well, the resultant force of that situation is what?
when it's horizontal, it's the upthrust. Upthrust is the one that's working. The weight doesn't come in anymore.
Yeah. Okay.
The weight equals to
That's
upthrust.
true.
When it's horizontal,
Wait, goes to upthrust because it's floating, is it?
so there's no resultant force. That's why we use upthrust
Yeah, is it
only.
because it's floating?
Be a bit louder.
Is it because the sphere was floating?
Can't hear you.
Is it because the sphere was floating?
Yeah, the sphere is floating. Right? The sphere is floating. So it's not fully submerged. So the upthrust is the what that balance the weight. So the upthrust
Oh, okay.
causing the clockwise moment. Okay,
Yeah. Oh, so it's quite a hard question.
okay, we are alright. Let's carry on to the next question. On figure 4.1, draw circle around two particles which are exactly wavelength. There, there's your marking scheme. Oops, sorry. Can I'm hurrying up because your time is
Yeah.
running out. Can
Yeah. Yeah.
get on a graph to represent the displacement of particle of a quarter of period later. So if this is the initial one, then it will be that way. A quarter of period, it will be zero becomes at the maximum level. Say the direction of particle that at that time, that is here. So that is moving upwards. Oh, sorry. That is moving to, is a longitudinal wave. So it's moving to the right. Can
Ah.
any comment?
No.
Okay,
Well, what do they mean by t equals 0?
say again.
State the direction of motion particle z to the.
This is a T naught. So a quarter of period is 90 degrees. Here,
Oh, yeah.
right? It has
Yeah,
shifted,
yeah.
it has moved by a quarter of period.
Move to the right. All right.
Move to the right. Can and calculate the
Yes.
speed. Frequency is
Half.
given. Convert it to hertz. X and Y is half a wavelength. So calculate out the wavelength. Can or not? Anything not clear?
Yes. Yeah, clear.
I just give you the answer lah. Since our time is almost finished already. Okay, anything that I need to explain?
I don't have. Mostly I'm just scared of the electricity questions.
Electricity will come out one. Can or
Yeah,
not?
yeah. All right, thank you, Rachel.
Yep, can or not?